So thank you for a very generous introduction. Jason and I would really like to thank the Architectural League of New York. We, of course, would like to thank Anne and Nick, who's walking right in, for all of their help and support in putting this whole event together. Of course, the New School and Bill Marsh, especially for hosting the event and making the possible. So Jason and I are going to split this presentation into 20 minutes that are allotted for us. So we wanted to start by giving you an idea of our kind of larger conceptual framework within which we actually work, and then kind of launch into a couple of the more recent projects that we've done in the last couple of years. So the challenge is it's different. So for us, it's different means that it's no longer pure. It's scrappy, messy, hybridized, connected, and alive. To survive, our design practice has had to be inventive, nomadic, and promiscuous to a certain extent. We've had to experiment with and deploy a range of ideas and tactics from fields that are outside of the discipline of architecture. Geography, robotics, biology, material sciences, and advanced fabrication are just a few of the different types of tactics that we dabble in. The results are often unexpectedly grotesque, sometimes ugly, and are quite often at odds with what our education essentially prepared us for. We've invented this term, live models, to describe what we make and to differentiate how we practice. Live models are dynamic formations that register and continuously adapt to shifting conditions. They require multiple inputs, and some people would say multiple participants, to actually thrive and evolve. These live models can be used as analytical engines to kind of understand social, cultural, or ecological patterns around us, or actually as conceptual frameworks for architecture and design. The most compelling of these models do not merely depict the kind of mere appearance of things, but seek to reveal the irreducible nature of the behavior and processes in transition. Not only are live models capable of calculating the underlying logic of these processes, they also reveal underlying organizations and emerging organizations and visually discernible patterns. These live models yield dynamic and spatial cartographies that are latent with real-time, open-source, user-generated data. With the advent of immersive technologies, these models are rapidly becoming experiential worlds unto themselves. These worlds blur distinctions between models as mere depictions, so models as just representations, and models as actually vital sensorial spaces that are live and impregnated with mutable and valuable data. What differentiates our practice is our willingness to wade in this complexity and relish in the ever-evolving and uninhibited terrain of design. So the couple of projects that we're going to go through test this idea of live models, and hopefully kind of elucidate a little bit more what we mean by that term. The Aurora project was the project we completed at the Alen Institute a couple of years ago. It was initiated as a series of 3 distinct design explorations that emerged out of an extensive study of the Arctic region and how the Arctic has been represented and in many cases misrepresented throughout time. The intention was to use these representations as points of departure for engaging contemporary political, social, and ecological issues. Each of the explorations attempted to translate or represent these issues through drawings and interactive models that were exhibited together, and here you're seeing a view into the exhibition space. So Terra Incognita, which is the middle set of light boxes in the space. Terra Incognita consisted of maps and diagrams that provided a view into how the Arctic region has been represented, claimed, and mythologized in past and present. The main interactive piece at the depth of the image, the Aurora model, superimposed the ephemeral qualities of these representations with a dynamic behavior of multiple users, translating the shifting dimensions of ice into a responsive light field. A smaller interactive instrument, the Glacier, which you're seeing right in the foreground of the image, complemented these kind of 2 larger installation pieces by engaging a smaller group of users' senses through the sight and sound of melting ice. Terra Incognita consisted of maps and diagrams that provided a view into how the Arctic region has been represented, claimed, and mythologized in past and present. So here you're seeing the past representations of the Arctic as a place of exploration. Voyagers would set off searching for the North Pole, only to kind of find that the ice would actually, and the environment around them would be constantly shifting and changing. So the representation of ice was the hardest part of the kind of documentation of this journey, this kind of voyage. So you're seeing Terra Incognita essentially as being this kind of terrain of unknown. And then the present representation, which is one that's mined and minted with so much data. This is the 2007 GIF image that was on the cover of the New York Times, showing the kind of transformation of the Arctic ice shelf from 2003 to 2007. The Arctic right now is rigged with multiple buoys that essentially provide information round the clock per hour of anything from sea ice extent to salinity levels to the consistency of the ice. So this graphic experiment concerned itself primarily with the dilemmas of representing something, in this case ice, that's in constant fluctuation. So through the study of historical maps and abundant contemporary real-time data from the Arctic, Terra Incognita experimented with ways to synthesize, map, remap, and remodel these representations that consciously oscillated between modes of dynamic modeling, cartography, and creative fiction. So here you're seeing 4 out of the 20 or so maps of the Arctic. So the same territory, the same region, just mapped and remapped in multiple ways. The main interactive piece, the Aurora model, superimposed these ephemeral qualities and actually synthesized those with the dynamic behavior of the users in the gallery, translating the shifting dimensions of the ice into a responsive light field. The model was constructed using a series of horizontal layers. And here you can see the multiple layers. So there's the kind of lower layer of the plaster cast buoys, the middle layer of the mesh tripods that actually support and suspend the surface of the Aurora model above that. And then at the top, you're seeing the kind of larger light field embedded within it. The model built itself up as a series of registers from bathymetry, temperature, salinity, ice thickness, ice age. All of those were embedded within the larger structure of the model. So here you're seeing the primary structure, you're seeing the model essentially plan, and the layers will build up through the next series of slides. So here you're seeing the, I think, 96 different plaster cast buoys that supported the larger structure, and here you're seeing the casts as they're individually made, fabricated, each one different because they're actually registering the depth of the Arctic Ocean as the kind of larger substrate. The network of stainless steel tripods that were individually soldered to actually support the larger surface, the hexagonal geometry that underlies the surface of the Aurora model. X marks the North Pole, and that line leads right to the Alen Institute, or New York. So you're essentially standing in Russia, looking towards the United States across the North Pole. The perforation pattern was related to the age of ice, so the kind of denser, older ice in the middle, and then the kind of much more porous, perforated ice shelf as it extends to the edge. And then the entire structure was rigged with a sensory mechanism that sensed its surrounding environment and responded accordingly. So you're seeing the 4 motherships essentially that control the entire structure. And these are all the layers synthesized, and the team, some of who are here. The entire structure was, although fabricated, hand sewn. So you're seeing Carrie and myself here piecing together the 4 larger pieces. So each module was essentially constructed, pieced together, sewn together, stitched together, and then kind of in 4 parts met its neighbors. For us, on the one hand, it was an indicator of our obsessiveness, but on the other hand, at the same time, we were really interested in the kind of fragility of the kind of hand-sewn seam versus the highly fabricated and highly controlled surface itself. Beneath that surface was all the wiring, so all the kind of underbelly of the structure contained all of the electronics, which were done by us. A lot of helpers. The responsive qualities of the Aurora model for us describe the way natural and artificial systems interact and adapt with one another. Left unattended entirely, the surface of the aurora model would be brightly lit, vibrant and kind of alive. Though through the kind of through the actual interaction of the audience would actually trigger a completely reverse reaction. The entire surface would darken and kind of shrink away from the trigger mechanism. So the blue X is essentially the infrared sensor that's sensing presence. And then as one approaches the system, it actually degrades the entire surface. So for us, it was, on the one hand, a connection with a very, very remote system, in this case the North Pole, but also its representation within the gallery space in New York. So as, in this case, this person's approaching the surface, the entire lighting system would actually kind of pull away. And here you're seeing a kind of fully lit, bright, vibrant top view of it. And with that, I'll pass it to Lisa.
So the Aurora project was essentially designed in a way that multiple people could, in a way, interact with this larger piece. It was about 12 feet by 10 feet wide. The glaciarium, which kind of sat at the kind of the back of the gallery, you can see here, was a very different idea. We were really interested in this notion that we would have a piece that would be big and collected, and another piece that would be about an individual's sort of interaction with the device. So the glaciarium essentially is set up like this, kind of exploded drawing of it. And what you're seeing here is essentially a frozen ice core, which sits in the middle of the glaciarium, which is demarcated in the kind of blue cylinder in the middle. And we designed basically this device to observe this cylinder of ice melting. So what happens is an observer looks through the kind of eye hole, looks at the kind of the ice melting. There's a sensor that's right here. And basically, the sensor is triggers a light, and there's a heat light that sits up here. And as you're observing the piece, the heat light accelerates the melting of the ice, and that comes down and gets a contact mic. The contact mic feeds this kind of speaker system and amplifies the kind of the sound of the melting through the gallery. So what happens essentially is over the course of the day, the piece would start like this, and after about 10 hours it would be fully sort of deployed into its catch basin. The idea was that the more the ice was in a way observed, the more the heat lamp would obviously trigger this and accelerate in a way the melting. So here's some images of the piece being used. We're really intrigued with the kind of interaction that began to happen. And you'll see in later slides how you're visually and kind of acoustically, almost sonically influenced. These are some images of the sort of fabrication process of the piece, kind of a CNC milled jig that the piece, the stainless steel outer kind of shell was laid over top of that, was sort of welded, and then within this, you're seeing here this kind of PET-G plastic interior landscape. This is Thomas Kelly, who built a lot of this, dropping the ice core into the glaciarium right before the kind of opening. Here you're seeing a view that's actually looking down into the piece. You can see the speakers here and here. And really, this is what the piece was about. Very different kind of idea. And again, this person is essentially looking through the sensors triggering it. The heat lamp is kind of being triggered. And what essentially happens in this piece, when no one's in front of it, obviously the ice is still melting, so it's sort of going like it kind of drove the Alen crazy actually after several weeks. But as you looked at the piece and observed the piece, it would obviously accelerate the melting. So you hear this sort of like this. The idea was that the piece became a kind of way to understand your relationship and kind of have this kind of understanding that your observation of the ice accelerated its in a way its kind of destruction. So we're playing these ideas, larger ideas of kind of time and entropy. This is actually looking through that aperture. It was really critical that this piece was absolutely stunning. We created this kind of interior kind of landscape in a way for the ice, and we really wanted to kind of compel people to look at next project we're going to show, I'm gonna have to kind of really push through these projects. The next project is sort of related. This is for a show at the Pratt Gallery called Zero Max Envelope, curated by Christopher Hite. And basically the show is all about dynamic envelopes. And this was a project that we did in which we deployed a kind of suspended surface in this gallery, and then constructed a series of kind of robotic flower petal pieces that responded to the proximity of people into the gallery. You can kind of see it's a kind of double-sided piece. This side is extremely opaque, facing kind of the windows of the gallery, and the back side of the piece, you almost sort of got into the kind of animal, into the kind of machine, into the kind of network. This is the kind of the brain. The brain was mounted essentially in the ceiling. What you're seeing is the kind of guide wires coming down to the servo motors and the kind of LED heads that you're seeing here. This is somebody basically interacting with one of the pieces. This is just to give you a sense of the kind of fabrication process that we're kind of going through with all of these. I'm going to kind of show our list of collaborators in the end, but none of the work that we're actually showing here could have been done just by Nataly and I. We generally have amazing people that are kind of coming in and kind of working with us. I think just to point out, I think our design practice, as Nataly mentioned, it's not necessarily a normative architectural practice. We're kind of routinely having to bring in people that are dealing with electronics, people that are dealing with fabrication, and it's a kind of very messy kind of environment that's actually producing this kind of work. This is again one side of the piece, and then in a way, this for me probably embodies what the piece is about. It creates this kind of suspended, kind of animated, interactive, and responsive geometry that puts you in a very different relationship with form and geometry. Super Galaxy is a project we did about 4 years ago, which in some ways is related as related themes. It was a competition proposal. I've always been sort of fascinated with this very strange building, which is across from the United Nations building in New York. It's the Donald Trump World Tower. It's this kind of black, monolithic, absolute sort of, I hate to say, it's kind of an atrocity. It's sort of this, this building that is such a funny building at that point in the city. We decided to take it on. We decided to look at what would happen if we embedded a kind of a 4-level sort of dynamic park. So we basically voided out several floors, 4 floors in the building, and thought what would happen if buildings had this kind of interior landscape that was completely open, kind of a sky and a garden. So here's the kind of large section of the Super Galaxy project, which looked at this idea of a kind of microclimate. So this would be sort of wild and open to the wind and to the elements, and then there'd be these interior kind of kinetic pockets that would in a way kind of rise and fall and kind of begin to kind of calibrate or kind of tune the interior kind of environment. Again, the section is just sort of looking at all these different apparatuses that would begin to serve it. And in a lot of ways, the last project I'll show tonight is sort of in a way related to this. And here you just get some sense of the kind of dynamic quality of the proposal. This is a competition proposal. It was just sort of a kind of provocation. But what's great about, I think, doing competitions is that we did this project, and there's a whole set now of sort of sub-projects that I'm going to show that kind of emerged out of this, things that we've sort of taken on, themes that we've explored. In our minds, this was a kind of fully kinetic, animated pieces. These pillows would sort of rise and fall. The ground itself would become a kind of digital display that would show, in a way, treat the kind of interior landscape as if it was a kind of weather map. So this thing would be updated in kind of real time. You would actually begin to see information on the kind of surfaces of the building, treated in a way like data. This gives you some sense of the kind of dynamic quality. Baby Sis was an installation proposal for the Extension Gallery in Chicago, which happened right after we did the previous project. So we were actually kind of interested in exploring these pieces. We had very little money, we had almost no time, and so we decided to take one of them on and build a kind of double curved kind of vault structure. We really wanted to make this out of glass. In this case, it's a 1/4-inch acrylic. It's essentially a 2-dimensional scissor structure that was suspended from the gallery and then pinned at the edges. So you create a kind of double curved vault through that. We worked with a sound artist who basically created this kind of robotic sonic field, which set of sensors that kind of envelope the end. And it was an effective piece, basically calibrated, set up for the opening, which is the exploration and how we could begin to kind of affect a kind of space with something like this. And this is a kind of view into the portal. In fact, we were really intrigued with this image. There was a little girl at the opening, and she actually got right in it and was dancing and had this amazing kind of relationship that she was really interested in. We were really interested in that kind of idea. So we pursued this project further. You'll see these are CNC milled aluminum kind of barnacles that kind of attach themselves to the piece. So the last project I'm going to talk about is a project actually that we decided to sort of display in the gallery. So we go to the gallery plant, you'll see this piece. The Thermospheres project is it's a very new project in the office. In fact, we just started this about 6 weeks ago. And the Thermospheres project essentially is a project for 3 thermal baths in Athens, Greece. And essentially what you're looking at here are, there's, when you go out to the gallery, you'll see there's a low one, there's a medium space, and a kind of larger lofted space. So there's a kind of cold, medium, and hot pool. So it's essentially a kind of a canopy structure that covers those 3 pools. But there's a kind of extended canopy, which you'll see here. We're really interested in the edges of this piece becoming a kind of urban promenade. And so you can see in this rendering, there's the kind of pools, there's this interior kind of landscape, and then there's this sort of extended field, which is this kind of upper kind of canopy. This is right on the site is right on the sea in Athens, and we kind of thought of this as a kind of set of microclimates that might begin to kind of create new kind of program types in the city of Athens. I think that's my phone telling me that the time is up. Sorry. And basically, the idea behind the kind of hydraulic legs was that the canopy itself could kind of move kind of up and down in a way to begin to kind of calibrate the kind of interior landscape of the piece. And this is just a really quick video to show you some of the processes and how we actually designed this canopy. You're seeing a kind of catenary, digital catenary structure that's essentially a digital hanging chain model. And then draped over top of that is this kind of canopy structure. That canopy structure is joined at these compression rings here. So you'll see falling kind of from the sky, this kind of draped structure. So what's, in fact, this took many hundreds of versions to actually get this right. In a way, we're just sort of hinting at how we're beginning to design. We're designing using kind of advanced computational methods, and it's just a very different, in a way, approach. I should add that Rick DeLeon, who's somewhere here, has done a lot of work on this project with us, and hopefully you'll meet him. I want to acknowledge that. This is the model that you'll see out in the gallery. And then some of the kind of process images of this model. Just to note, the entire model has essentially been hand sewn. So when you're out there, just pay attention to the kind of joints and all of the kind of joinery. It's hand sewn, not a drop of glue in this entire model. And so you'll get a sense of what that is. Here's a kind of section of that model that shows this piece. I'm going to point this piece out to you right here. When you're out in the gallery, please don't be afraid to get sort of down low, get on your knees and look up into the model, because you'll see this kind of hanging spike, which actually sits in the very middle. The idea behind this would be that the 3 kind of pools, obviously the kind of condensation and moisture over time would kind of calcify. The idea was that this kind of interior kind of structural skin would become this calcified kind of spike that would kind of grow in a way over time. It would begin to kind of build up this kind of calcified sort of object. That's just a kind of a pool. And then this is the final piece, the kind of internal set of geometries, the kind of hanging spike that you'd actually be looking at. So you'd look in one of these pools, you'd be looking up through this piece. I want to end by just acknowledging that a lot of our collaborators and also a lot of the institutions that have supported the work, obviously with kind of experimental practice, we've had a lot of different people in the office. I mentioned Rick DeLeon, but I should definitely mention Thomas Kelly, Carrie Norman, and others that have been a part of the practice and have really pushed us to do do this kind of challenging work. So with that, thank you for coming.